Okay, so now we're going to talk about the derivatives for vector valued functions. So if r of t, so our vector valued function, has its components x, y, and z, all functions of t, then the derivative of r with respect to t, which we can either write dr dt or r prime, we'll make r a vector still, of t, guess what? We just do it component by component. I love the parametric form. So x prime of t, y prime of t, and z prime of t. Right? So we just find the rate of change of each of the variables independently. Well, yeah, each of the variable components independently. Okay? So let's go ahead and practice. So if r is t cubed, cosine t e to the 2t. And you know, I keep writing these right in the component form. We could write them as t cubed in the I hat direction plus cosine t in the j hat direction plus e to the 2t in the k hat direction, right? That's totally fine as well, either way. Okay. So r prime, so the derivative is a vector. So if you take the derivative of a vector, you get a vector. So the derivative, r prime, so first derivative, so we'll get 3t squared. Derivative of cosine t will be negative sine t. And the derivative of e to the 2t, so remember your chain rule, so 2e to the 2t. So you can kind of think about this, right? If you have, if you were graphing, these vectors for r, the rate at which those vectors, the tip of the vector is changing, can be described by this other vector, this rate of change vector. Now we can find a second derivative. Exactly, we just take the derivative of the first derivative. So we'll get 6t, the derivative of negative sine is negative cosine t, and then bring down another 2, so 4e to the 2t. Okay, so just like with regular derivatives or derivatives of regular functions, we had some rules. So let's talk about the rules when we're differentiating vector valued functions. So we'll let u and b be our non-zero vectors. So we have the sum and difference rule, same thing. So if we take the derivative of u plus or minus v, I know you know what that's going to be, right? It's the derivative of u plus or minus the derivative with respect to t of v, right? So you can either add them and subtract them first and then take the derivative, or take the derivative independently and then add them together. Okay. Constant multiple, so if you have, so c is a number. If you're taking the derivative of a multiple of u, then you can just move that constant multiple out in front. Take the derivative of u and then take your multiple back through, either way. Okay. Product rule. So this is not multiplication. So when we're talking about products here, there's actually going to be kind of like 4 different flavors, that we're going to talk about. So this first one, I'm going to let f of t represent a scalar, so one of our regular old functions from before. So it's just going to be f of x f of t equals some one component, function. If I have that scalar function times our vector function, and I want to take the derivative, it's going to be our standard product rule. So it'll be, the first, so our regular function, times the derivative of the vector function, and then plus the other way. So the derivative of the scalar function times the vector function. Okay. And then you would combine your like terms. Okay, so we have one more rule, and that is, that I'm going to do now. I'm going to do a separate video for dot product and cross products. But the chain rule, so if g of t is another, so let g of t be a scalar function, so just a plain old function, and u, so our u vector function is evaluated at g, so this is a composition. Remember that, composition. So when we do the derivative, it's u prime, so the outer derivative evaluated at, the inner, and then times the derivative of what's inside. Okay, so let's go ahead and practice. Okay. So I have a u vector, t squared, comma, square root t, comma, 1 minus t. I have my f of t is e to the t, and my g of t is sine t. Okay, so what's the derivative of 5 times u of t? Okay. So I'm going to take the derivative of u. So the derivative of u, we're just going to go, right, term by term. So 2t, 1 over 2 square root t, negative 1. And then we'll distribute the 5. So that will be 10t, 5 over 2 square root t, and negative 5. That is the rate of change. Now, what is about my second one? I have the derivative of f of t times the vector u of t. So I need the first, so I need e to the t times the derivative of the second, so the derivative of u. So here's my f times u prime. So that'll be times 2t, 1 over 2 square root t, negative 1. And then plus, so this is first times the derivative of the second. Now I need the derivative of the first. Oh, derivative of e to the t is just e to the t. Okay, times, so this is my f prime. It just happens to look the same as f. And now that'll be times u. So times t squared, square root t, 1 minus t. Okay, so I'm adding the two vectors together so I can distribute my function on the outside. Right, so I'll have e to the t times 2t, and then e to the t over 2 square roots of t, and then negative e to the t, plus, same thing over here, I'm going to get t squared e to the t square root t, and then e to the t times 1 minus t. Oh, I can barely fit. Okay. So if we add those together, last version, it's going to take a lot of space. So I don't see any like terms, but we're going to add our x components. So I'm going to get e to the t times 2t plus t squared e to the t. For the y's, I have e to the t over 2 square roots of t plus e to the t times the square root of t. I see some simplifying here that I'm not doing, and I feel kind of bad about it. And then for my z components, I'm going to get negative e to the t, plus e to the t, I'm distributing over here, and then minus e to the t times t. So these guys could definitely cancel. And we could make that look a whole lot prettier. Okay. Last one. So this is our composition. I have u evaluated at g of t. And so I will do u, right, u prime. I need u prime evaluated at g, and then I'm going to multiply that by the derivative of g. Okay, so u prime. So where was my u prime? Can you see it up there? So u prime 2t, 1 over 2 root t, negative 1. Okay, so we're evaluating this function at g of t, and g of t was sine t. Okay, so this first part is over here. So I'm going to have 2 times sine t, 1 over 2 square root sine t. Negative 1 is just a constant. I don't have a t to replace there, so that'll just stay negative 1. Okay, so here's my u prime at g of t. Okay, and now I need g prime. So what's g prime? So that's the derivative of sine, and the derivative of sine is cosine t, of course. So now we multiply those two together. So I have cosine t multiplying in to 2 sine t, 1 over 2 square root sine t, and negative 1. So that will be 2 sine t cos t, 1 or cosine t, over 2 square root sine t, and finally negative cosine t.